How are we doing? You all right?
Good. Good. That's go with the week, 9 weeks. It's very exciting. Yeah. So much bigger.
Yeah.
Not gonna be relaxed. My oldest starts to like that's what it's at. Like that's what jobs. Yeah. But also now, it's 16 years before you do such a long trip.
Good. And you know, it's fabulous.
I do have that thing to make sure that
You know, our businesses. I mean, that's dealing with AI. No, good. Yeah. That's. Stop smarts. That's like they're like. Something shake. But there's lots. Yeah, I think so. Yeah, 19 years experience. We need to do that. Not many people are trusting stuff. Yeah, it's
let me get
Hello, hello. All right, we'll kick off in 2 minutes. Just let the last people come in, find a seat.
Getting on. That fast.
Okay, we'll get going and let people come in if they're still finishing up pizza. So welcome to Cloud Native London. We are a strong, open, diverse developer community around cloud, data, and AI. Now in our 9th year, I believe. My name is Cheryl. I am your host for tonight's events. Tonight we have 2 talks for you. Is this microphone on? Can you hear? Okay. Hello, hello, hello. Speaking. No? Okay. Might have to shout tonight then. So we have 2 talks for you. We have Universal Mesh, Connect and Secure Everything at 6:45. And then 7:15 have Building Abstractions that Matter, Developer Platform on Kubernetes. Try again. And we're going to wrap up and go to the pub afterwards, the Conductor, which is just out this building in front of you on the left. Our sponsors for tonight are WSO2 and HAProxy, who are going to give their introductions as part of their talk. And then Tech Shack, I'm going to read out the little introduction for them. TechShack are a tech recruitment agency specializing in the cloud, engineering, and AI. TechShack exists to build high-performing tech teams by putting community, connection, and quality first. And their vision is to create the most trusted tech recruitment community. So thank you to all of these for making these events possible. Palumi, I think Dipali, yes. Okay, are you going to do a little intro? Why don't you come and do the intro? Oh.
Hello, hi. I'm not Dipali. My name is Alberto Pose. I did a talk during May last time. So yeah, Pulumi basically is a solution to do infrastructure as code. So similar to Terraform, but basically you do it on your own programming language. And basically we have a solution that's an enterprise solution to manage your resources, your AWS resources, your GCP, your Kubernetes cluster. So we have a solution for that. If you would like to know more, please scan that QR code, and I'm happy to find you during the recess to discuss what Pulumi does and if it helps with your use cases. So thank you very much.
Thank you very much. Thank you. And now, Dana, would you like to come and tell people about another event?
Hey, everyone. So happy to be here. I'm leading CNCF other local community and past ambassador. So really excited. We have a great meetup tomorrow. And thank you so much for coming and sharing this meetup. We have a bunch of amazing people. We have Kodo and Bond AI community collaborating with few some local communities. And we have a really amazing panel. Kunal, some of you probably know, going to moderate with some people that here in the crowd, you can know this by the picture. So you're more than welcome at 6 o'clock tomorrow at Sivo. Yeah, and I think the next one. I'm from Kodo and I'm open source and community leader. Really proud to have Kodo free for open source maintainers. So it's basically the agentic AI code reviewer for free for maintainers, unlimited tokens and cloud usage. So if you know maintainers, would love to be connected. And if you're owning a community and you would like to have sponsors, we would love to sponsor it. So thank you so much.
Thank you very much, Shanna. Thank you. Okay, thank you to all of our sponsors for supporting us this evening. Now I want to find out a little bit about you. So please grab your phones if you can and scan this QR code. We're going to do some live polling. You don't need to download anything. It will just send you to this Poll Everywhere service. Ask 2 questions about you and 2 questions on how you use cloud data and AI. And first question, is this your first time at Cloud Native London? You should see a yes or a no. Just hit whichever is your first time or not. Looks like we have quite a few returning people, which is wonderful as always. But if it is your first time as well, I'm very happy to welcome you here. Those of you who came a long time ago might know that we were in here up until about in this venue up till about a year ago and have been moving around a little bit, but now thrilled to be back here as well for the first time and staying here for the foreseeable future. Next question, what is your job title? So pick whatever's closest to what you do. Your choices are architect, application developer, backend developer, engineering manager, DevOps/platform engineer, security, or anything else. And looks like there's quite a mix, just a spread across different ones. We're also live streaming this on YouTube and on LinkedIn. So there might be some people at home who are joining us and joining on this live polling as well. Good. Next question. Where are you hosting production workloads today? So everything in a Kubernetes cluster in a single cloud, everything in Kubernetes clusters on multiple or hybrid cloud, combinations of VMs and Kubernetes in a single cloud, on multiple clouds, everything, or Cowboy Neil's mum's basements. Give people a moment to think about this. And this question came from Mark, who is our first speaker. oh, people are still voting. People let the numbers settle down. So, oh, surprising number of people just have it all in their basements. What do you think about that?
As expected, really. Well, with universal mesh, it's an alternative approach to being able to discover and route traffic to different workloads, which is more complex than service mesh can generally handle, because you have lots of different clouds, lots of VMs as well as Kubernetes. So it's not all that simple.
I was saying earlier that if everybody has everything in Kubernetes cloud in a single, everything in Kubernetes clusters in a single cloud, that would be amazing, but that would be surprising if it was so simple. Okay, next question. When a developer in your organization wants to deploy a new service to Kubernetes, what happens? Can they do it themselves in minutes? They first need to read lots of documentation in YAML. Do they need help from a platform team? Or we don't know, we've lost track of everything. Okay, what are we seeing? We're seeing pretty good, I would say. Like a third of people saying they can do it themselves, but then, yeah, a bit of a mix. So what did you expect to see from this question?
Yeah, I expected that it would be a mix. And so it's good to see that they do it in minutes. For the rest of the people, I think the talk would be very interesting. Yeah.
Fantastic. All right, thank you. Thank you for taking part in the live polling. Keep this open on your phone. We're going to do Q&A with speakers from the same, using the same service. I need a selfie for social media, so everybody just stay put where you are. I need a big smile and a big wave, okay? You have to look really happy. Wait. Nice job. Thank you very much. If you want to come and speak at Cloud Native London, you just go to cloudnativelondon.com to submit a request for a speaking slot. I think we're now booked up mostly through like the first couple of months of 2027. So just plan ahead and, get your request in early. You're also welcome to sponsor us and to promote your own events, product launches, whatever company stuff you think might be interesting for this community. And that is it from me for the moment. So now I would like to welcome Mark to the stage. Round of applause, please. This should go at the same time.
Hello. Hello, everyone. Thanks for coming. My name is Mark Boddington. I'm a solutions engineer at HAProxy. If you don't know, HAProxy is an open source project which has been in development for around 25 years now. We have an open source version and also an enterprise version. So if you're using HAProxy community today and you're looking for some kind of support, or if you want to look at some of the more enterprise features, so get things like security, web interface, or a central API for managing your various HAProxy deployments, then you can come and speak to us and we can help you with that. So today I'm here to talk to you about universal mesh, which is kind of like a high-level design pattern for deploying HAProxy in distributed environments to help you, to help your teams discover and make use of existing services, which maybe are in different locations throughout your environment. So could be on multiple different clouds. Maybe they're services that you've acquired from other businesses. When you make an acquisition, quite often you'll bring in technology and then you need to integrate it with your current stack. You can't just lift and shift all the time. So you quite often need a way to route to those those new services. So Service Mesh, which has been around for quite a while now, quite a few years, it was designed to solve connectivity, but really it was focused primarily on Kubernetes. And for most organizations that have grown through acquisitions and don't have everything in containers or on Kubernetes platforms, it doesn't meet the requirements. And this is, as I said, because the enterprises generally, it's not all greenfield. There's lots of brownfield environments involved. The enterprises have evolved over time. So they maybe have some legacy applications running on virtual machines or even physical servers. All of the new stuff may be in Kubernetes, but there's probably a few APIs, a few services you need to call which aren't running on modern frameworks. So for that reason, you need to link these new services with the old ones. And it's not always necessarily in the same place either. Hybrid cloud is quite a common for customers we speak to. You probably have some stuff on premise running in physical data centers as well as various clouds. Maybe some data is in Azure, maybe in AWS, etc. And most service meshes weren't built with this in mind. As I said, they were built really for the modern environment. The other issue with service mesh is there's a mesh tax we often hear, where there's obviously running sidecars on a container environment isn't free. So you have compute costs and memory costs for running the sidecars. Even if it's sidecarless architecture, there's still some additional compute costs involved with running those additional services. Managing north-south traffic is often managed by something else, so either an ingress or some other load balancing service to manage north-south. So it's not simple, and it does require some additional thought. If you're federating or using multi-cluster setups, then obviously you need some additional components, and they weren't necessarily part of your initial mesh deployment. So universal mesh is different. As I said, it's more of a design pattern than an actual product as such. It's a way to make use of all of the various HAProxy components which we provide to stitch them together with a central API using all of your various HAProxy deployments. HAProxy is software, so it can run pretty much anywhere you can run Linux. So that includes physical machines, virtual machines, and also containers. So we take the advantages of a service mesh, and we spread that out across multiple different clouds, multiple environments, using HAProxy and a central control plane to manage the configuration on those proxies in such a way that you can effectively access any service in any cloud in any of your environments by using a well-known URL pattern that you're free to decide for yourself. I'm going to have a demo in a little bit where we're basically having an application name in the path, but you could equally use host names and things like that as well. So there are two parts to the universal mesh. There's external access. So when the client is external to your environment, they would come into an edge HAProxy device at a particular URL. So the example here is that they've requested payment gateway on your mesh URL. The HAProxy, all of the HAProxys are orchestrated. So the edge HAProxy knows where that payment gateway service is located. In this case, it happens to be some virtual machines running on-prem. So the edge HAProxy simply forwards it to the HAProxy local to the service, and then that HAProxy knows how to route to that payment gateway. There's also an internal routing method as well, and that's where one of your services, one of your applications inside a cloud. So in this example, we're using Google. So a pod or something maybe running in Kubernetes on Google Cloud needs to access the same payment gateway. Again, they talk to, in this case, a local HAProxy instance, which will check two tables. It will first check to see if the service is local, and if it is, it can obviously route to the local pod. In this case, again, payment gateway is running in your on-prem data center, so it routes it to that HAProxy in that remote location, which then routes it to the payment gateway itself. So the thing tying all this together, many of you are probably familiar with HAProxy. As I said, it's open source software, been around 25 years or so. We also have a control plane for HAProxy, which is called Fusion. And the Fusion control plane is a central API that can orchestrate all of these different elements. It has service discovery functionality built in, so it can talk to Kubernetes or console and discover where your various applications are running, both in Kubernetes and outside. It can provide security management, so things like application DDoS protection, WAF, bot management, so threat detection as well, so we can detect vulnerability scans and stuff like that. But Fusion manages all this from a central location and also gives you observability into what's going on. Now, because Fusion is managing the configuration for all of these different deployments, that's how we can build the universal mesh using our various technologies. And as I said, it's very much a high-level design, and we can work with you to dive into the details and build something that works in your environment. One of the first customers that we have who have deployed this are PayPal, and they have a project they call Meridian, which is pretty much using this design pattern so that as they grow and bring on more services, they do a lot of acquisitions at PayPal. So as they're brought on new services, they can actually bring them into the mesh and make those services available quickly without, with much less hoops anyone has to jump through. So time for a demo. This wasn't working 5 minutes ago, so we'll see if it is now. Let me come out of this. Drag that over there. Okay, so, oh, that doesn't look good. So we have here a demo page, and this is accessing /payment/demo, which is an application that I've deployed somewhere on the mesh. Now it was working. Let's refresh. Oh, look, it's still working. Awesome. So what's happening is if I come into Fusion and search for that request, we can see, oh, yes, 1 sec. So what's happening is you have a request come in for payment demo. In this case, it came into the US front end. So this came into the front end of the mesh, so an external service. The US West location knew it wasn't located in that particular region. So it forwarded it to the EU West backend where the service was running. We then have the next request, which is probably, no, it's not that one. So this isn't, so this one is where it comes into, no, that's still. Never do live demos. Aha, get rid of the cluster. There you go. Try that again. So this one came into EU West, went to the US backend, and the server won. And in fact, there is a good way to do this. If I go to my log details, search for the correlation ID. Now, the IPs are being spoofed, which is why they look different. But one of these you can see is as a request of internal payment demo. And this is the one that went from one HAProxy to another. So this one came into the EU West location and was load balanced to a Kubernetes backend and to a Kubernetes pod. The correlating external ingress came into EU West and was actually load balanced locally in this case. So you can see these two correlation IDs, and this is the traversal of the universal mesh in action. The way the Fusion detects and picks the mesh up is through some annotations on the actual services themselves. So we have, so when you create a service and you want it to be used in the mesh, in our example, what we do is we have an annotation of edge name, which tells Fusion which edge is hosting this particular service. And then as we're using paths for routing, you have a regex, which tells it how to match different, how to match the path and what traffic should be picked up by this particular service. I do have another one here that is going to expose another route, hopefully. So if I hit this URL, which returns a 503 currently, because if you try to access a service on the mesh that doesn't exist, it's just going to return a 503. You could return any other page you wanted to. But if I apply this second demo environment, it's going to create some services that are then going to be picked up by Fusion, registered into the mesh. Then after a few minutes, we should see, hopefully. Let's get rid of this. Continues. Okay. So are they still? Okay, so they're running. Oh, there you go. Ta-da. So yeah, so you can pretty much deploy any app on Kubernetes or VMs, and then as long as you've got service discovery set up with Fusion, Fusion also has an API, so you don't have to pull the services in. You can push them to Fusion as well. But then once you've got the universal mesh running, you can pretty much deploy apps and have other services discover them and start using them immediately. Am I early?
15 minutes.
15 minutes. I'll do a dance.
Yeah.
Let me see. I'm sure I have some more slides. So, so we did the adding a new service thing. So key takeaways then. So the universal mesh is a high-level design pattern for using the various software components of HAProxy. So HAProxy Enterprise, along with the Fusion control plane, to deploy a universal mesh that works across different environments. So it's one mesh, works on every cloud, and provides ultimate simplicity once you've set it up and got it running. HAProxy and Fusion provide, essentially limitless tailoring for that low-level design, so you can make the mesh work pretty much in any way you want it to. As I said, in our environment, we're using URL paths off of a single FQDN, but you could have multiple FQDNs if that was better for your environment. And it helps you simplify discovering new applications and routing to them across different clouds. So, thank you.
First question, is Fusion an open source component too?
No, Fusion is not. Fusion is a enterprise. It's an enterprise service that we actually include with HAProxy Enterprise. So anybody who purchases a HAProxy Enterprise license gets a Fusion license for free so that they can manage a whole fleet of HAProxy Enterprise instances.
Okay, Istio went ambient to kill the sidecar tax. Is Universal Mesh one less thing to run or another control plane next to my mesh, VPN, and firewall?
Well, if you're using HAProxy Enterprise, HAProxy Enterprise provides a lot of additional security elements. So you can probably consolidate a lot of those components into a universal mesh. You wouldn't necessarily have to run a sidecar and a firewall and VPN and various other security components because we have a lot of those within HAProxy Enterprise, all managed from the Fusion control plane, making up that mesh.
All right. I help teams delete service meshes they never needed. Oh gosh, it's moving a bit fast. So what does Universal Mesh let me delete, not add?
Well, if you already deleted the service mesh they didn't need, you could probably delete some ingress controllers, probably some WAF boxes and things like that. As I said, HAProxy Enterprise includes bot management, web application firewall, threat detection, vulnerability detection, lots of components which can all be managed from a single control plane. In fact, something I didn't show you was the mesh. You saw a few 403s when I was reloading. That's because we have a security control plane that I'd applied to the mesh that was blocking some of the requests. But I kind of skipped over that. But yeah, so there's a lot of things that HAProxy Enterprise can do. So you can delete a lot of elements.
All right. Strip the marketing. Is this Istio's architecture with HAProxy instead of Envoy? And where does the proxy actually run per pod, per node, or per gateway?
That's up to you. I mean, not everything runs inside Kubernetes. The diagrams are trying to show that you can run HAProxy Enterprise pretty much anywhere. It could be on a virtual machine. You could run it on a physical box if you need absolute performance. So at your edge, for example, you could run on physical boxes if you wanted to. Although we have customers doing, 10s, 20, even 40 odd gigabits into Kubernetes pods running HAProxy. So as I said, it's more of a high level design. We're not forcing a sort of a one size fits all type approach on customers. It's more of a consultative thing. So universal mesh is something that we can tailor to fit pretty much anywhere.
Gosh, unify north, south, and east, west, and you unify the blast radius too. When it fails, what goes dark, and what's my way out?
So Fusion is the central control plane, but it's not actually involved in any of the decisions in real time. So it doesn't matter if the control plane falls apart or one of your HAProxy dies. Then obviously, Fusion dying or going out doesn't actually affect the service at all. It just means that you can't put new services online. So if you were to deploy a new service while Fusion was unavailable, then it wouldn't become available in the mesh. But everything already in the mesh would continue to function. If you lost the HAProxy itself, then obviously if it's running in Kubernetes, then Kubernetes would in theory restart it. If it was a VM, then maybe some other HA components you have would bring it back up. But HAProxy has HA itself. Obviously, it's in the name. So we run things like keep alive D and things so that when something goes wrong, one of the core fundamental features of a load balancer is to keep you running. So, we've been doing HA for a long time. So hopefully we'll get you out of it.
Okay. Isn't central management a weak point rather than a distributed management solution? Can I manage using Terraform / Pulumi, etc.?
Yep. So Fusion is one of the things Fusion provides is a central API. We actually build Terraform providers and Ansible collections for managing the Fusion control plane. In the new version of Universal Mesh, we also provide or can provide a Kubernetes operator to help drive the Fusion control plane directly from Kubernetes resources as well.
Which of these features are universal mesh and which are enterprise?
So enterprise is the commercial version of HAProxy. Fusion is the control plane, and together you can use them to build a universal mesh tailored to your environment.
Okay. Is traffic re-encrypted between Fusion and local HAProxies?
Yep. So all of the communication between Fusion and the HAProxy instances is encrypted. But that is all management traffic. There's no communication. Fusion does not sit in the critical path for any data. So when one HAProxy receives a request, it gets routed directly to the destination HAProxy, where the pods or the VMs are running. And that can be encrypted. It can be clear text. Like I say, we give you the tools, we help you. But if you want everything end-to-end encrypted, which is probably a good idea, then yeah, absolutely, you can do that.
HAProxy's reputation is doing one thing better than anyone. Isn't universal anything the opposite of that? Philosophical question.
Well, the one thing we're known for doing really, really well is being very lightweight, fast, efficient, and delivering, HTTP services fractions of milliseconds. Universal mesh just gives you a modern framework for managing the configuration. The thing we do really well, we still do really well.
How does this deal with actual legacy applications which aren't webby?
So older applications, you need some kind of service registry. So something like console, for example. So you have your VM spin up, register the services with console, and then Fusion can pick up the elements from there. There's also nothing stopping you hard coding your legacy applications. If they've been around for years and they don't change, then just write some config and put it in a piece of YAML and attach it directly.
Can I route to an army of Raspberry Pis?
Of course you can.
Why universal mesh? What's universal and not service?
Service mesh was taken. And universal because it's not related to Kubernetes or containers in any way. It's about connecting your farm of Raspberry Pis to what you're running in Google to what you're running on-prem. So it's universal.
How is the data plane traffic encrypted?
TLS, like everything else.
Is HAProxy a hybrid cloud service provider, which has AWS, GCS, etc.?
No. So we don't run any cloud services for customers directly. Although having said that, HAProxy 1 includes a service called HAProxy Edge, which is a competitor to Cloudflare and Akamai. So if you're looking for an ADN, then we also have a solution for that.
Still got 5 minutes. Can custom plugins be written/added to extend the capabilities? For example, imagine a proprietary authorization server at a bank.
Yes, absolutely. I mean, that's standard HAProxy enterprise functionality and community. Actually, we support extensions through Lua. We have a thing called SPOE, which is Server Processing Offload Engine, which enables you to write extensions in your own language, a bit like Pulumi, I guess. So SPOE, you can write a plugin pretty much in any language you like. Obviously, we have the whole of HAProxy is written in C, so if you can write a plugin in C, you're welcome to do that too. Otherwise, we have Lua as well.
Which packaging metaphors do you support?
I don't understand the question.
Someone in the room, let me give you the microphone for the live stream.
Basically, the question is, you're talking about this being multi-cloud, multi-provider, different types of infrastructure. What types of infrastructure can it run on? Is it a Windows MSI? Is it a Debian package? What? Because we've talked a lot about it being Kubernetes, but not limited to Kubernetes. Trying to get a feel for what does it run on other than Kubernetes that isn't a containerization platform?
So it can run anywhere. You can run Linux. So it's C software. We provide Docker containers. So if you are running Kubernetes, we have an image you can just download and use. That is built so that you can actually just give it what we call a bootstrap key. And then when it starts up, it will go and find Fusion all by itself. Other than that, you run it on operating systems. Obviously, we provide AMIs in the cloud providers. So we're on the marketplaces, etc. Otherwise, you just deploy Linux and then apt-get install or DNF install or whatever, depending on your platform.
Service mesh adoption stalled because the complexity never paid for itself. Isn't a universal mesh just a bigger bet on something the market's already quitting? More philosophical questions.
I think so. Load balancing has been around for at least 25 years. It's going to be probably around for another 25 years. This is just more of a control plane for that. Maybe service mesh adoption stalled because of the issues around trying to support multiple clouds, legacy environments, etc. Universal mesh is trying to avoid those issues by because HAProxy can run anywhere. Universal mesh can run anywhere. It's not limited to a particular environment. As new deployment models come out, we will try to support those. So it's too early to say, maybe. Fingers crossed it works out.
Is non-HTTP traffic supported? WebSockets XML?
Yeah, WebSockets, absolutely. XML services. Again, the examples we showed were using URL paths to locate the service. As I said, you could use FQDNs or even port numbers or whatever makes sense for your environment.
Can you elaborate on the use case similar to the demo where you need to toggle between different domains? How fast would the propagation be? Is there some sort of sticky session to invalidate?
Possibly. So you mean if a service moved from one location to another, maybe. So the configuration is stored in map files, which can be updated via API. So the only latency would be how quickly those map files were updated. If you're using service discovery from Fusion, then there is a timer on that, so you can set how frequently we recheck our configuration. And that can be down to a couple of seconds, maybe even 1 second if you wanted it to. So I guess 1 second resolution is probably the lowest.
Okay. All right, you want to take?
Subdomains. And there are a lot of services that create subdomain for you. Like, can you support that use case? HAProxy provides different subdomains and doing the routing. Because my concern is you are doing some sort of sharding and you need to move kind of people around. That's really tough, right? And if it's gonna take hours, you need some offline time, right? So I was wondering how that feels good because I think the route is kind of equal, right? It's a path, but when you change to subdomains, you also need to take into account the caching from the client side, right?
Yeah, DNS always has that caching issue. I guess adding new subdomains isn't a problem, but yeah, if you move one, then you've got the TTL to deal with. We do actually include a global server load balancing solution as part of enterprise, and you can set the TTL as low as you like, but not all browsers will honor that. So yeah, I mean, if you're using the FQDN method, then potentially you're looking at maybe a minute to move something.
Okay, we're going to do one last question. So can the universal mesh do region-aware routing, so the same service in 2 regions and request its region X, so it routes to service in region X?
Yes.
Good. That was nice and fast.
I mean,
Okay.
yeah, so you absolutely can do that. We can even do availability zone aware routing if you want to. So if you don't want to run the risk of routing from one AZ to another and paying Amazon more money than you want to, then obviously you can look at that as well.
All right. Thank you very much. Round of applause, please. I think that was a record for the number of questions we got through. So thank you, everybody, for submitting lots and lots of questions. And now I am going to hand over to our second speaker. So over to you.
You hear me with this mic? So today I'm going to talk about building up abstractions that matter. So that's the topic that I'm going to discuss. And today I'm going to talk how these abstractions we have used in WSO2, and we have created a developer platform on top of Kubernetes. So I'm Chaamini Mangaleswaran, and I'm a lead sales engineer at WSO2. For the people who doesn't know about WSO2, we are an open source company. We have been here for more than 20 years. Predominantly, we were an integration focused company, and now later, over time, we have products in the space of API management, identity and access management. We do have our own internal developer platform. And also, we do have our newly released agent manager as well. So before I start, I would like to have a raise of hands, like who has an internal developer platform in your organization already, or who is building something towards it? Yeah, so I see a couple of people who are already in this space. So to give you some context, what is a developer platform? So as an engineer, you are the person who needs to create your user experience through your code. And that code has to be shipped to your production environment, and that's where the actual business value comes into picture. So when you are shipping this code from your laptop, from your code repository to the actual production, there is a long process that's involved. So you have to get it first into your non-prod, like the lower environments. You have to test it. You have to securely send it to the upper environment. So there's a long DevOps, SecOps. So there's a big platform that's get involved. So, and there, like you need a platform that can simplify that to an engineer, so they don't need to worry about the internals. They need to really worry about how you can create your business value through your code, but not worry about the internals within how to ship this code to your production environment. And that's where the developer platform comes in. And this developer platform is the responsibility of the platform team. So it could be your DevOps engineer, your platform engineer. So they have to build this platform for the engineers to simplify how they can run their workflows. So we have two user personas here. One is the platform engineer and the software engineer. And now with the agentic enterprise, we also see this can be not only humans, even it could be AI agents who are doing this task. So, and in some organization, we do have a clear separation of a platform team and a engineering team. And in certain small organization, a same person could wear this hat for both. So now we're gonna see, so now this internal developer platform, how is this adoption within different organizations? So these are certain metrics that we have, certain analysts have carried out. So a lot of organizations are spending on creating these internal developer platforms. And if you see, it's more than 4.2 million. And the Gartner predicts that organization will have a dedicated platform team by end of 2026. But if you see whether the engineers are really using these platforms, not really. So you can see like 64% of the developers just bypass that. So why? So why this adoption is failing? So that's what we are going to answer through my talk today. So let's keep this question open, and let's talk about how you will create this platform. So to create this platform, as you know, like we do have a lot of cloud native technologies available. For example, like Kubernetes, Argo CD. So you can take these different tools plug it in, glue it, and you can make your infrastructure more powerful and flexible. So it has to really ease up what's being carried out. But the problem here is, so the platform engineer does it, but then the developer needs to have an interface where he does not need to worry about what's going underneath. But the problem is we do have this platform layer, and we are introducing that to the developer where the actual complexities of the infrastructure is leaked to the developer, and the developer experience is hindered. So how can we solve this? So at the end, what happens is the developers ask, why so much YAML that I have to deal with? So I'm writing my code, do I write the YAMLs? So how do we solve this issue? So of course, the platform engineers, they like to deal with the YAMLs. They like to create their own platforms, glue all these tools together and provide a comprehensive platform. And so let's talk about abstractions. So now Kubernetes, when Kubernetes came, that gave a very good infrastructure abstraction. So everything was abstracted, the compute, networking, and storage. So if you want to auto scale, if you want to just get 3 nodes up and running, you don't need to worry about where it's running. It happens automatically. You trust it. So does this infrastructure abstraction means the developer abstraction? Not really. So when we think that the infrastructure abstraction makes the development quicker, that's where we are making the fault. So now Kubernetes is not the problem. So we do have the infrastructure API. And on top of that, we do have certain API for the developers to work on, but that's not enough. And that's where we need to have this abstraction layer. And how do we do that? So there should be another abstraction layer, and that is where we bring in these APIs. So what it does is, like this API abstracts what the platform does, and it gives to the developer in the way they understand. Because how the developer thinks is something different of how a platform engineer would think. So for developers, so they do have these services. They know that there are interdependent services. They have to connect to the database. So those are the things they worry about. But underneath how it is done is not really needed for a developer. And now when we talk about abstractions, this is not something only for platforms. So if we talk about the programming languages, so there were days where we use assembly, and now we don't use that. And if you take JavaScript, there are very few people who write the code in JavaScript. So we use frameworks like React, Angular to just abstract it. So the developer, what he has to write is minimized. And when you really do these abstractions, actually the result would be less code. And for example, if you're using a code agent and you are trying to understand your YAMLs, you'll be really using fewer tokens. And that could even be cost effective for your organization as well. So to answer this, we have come up with a framework. It's an end-to-end platform, which is Open Choreo. This is an CNCF sandbox project, which was created by WSO2. It's a complete open source project, which you can ready to use from day one. So I'm going to talk about how we have solved these issues. So the end goal is the developer and the platform engineer coexisting happily, and that bridge is through an integration and developer platform, which is Open Choreo. So here, so this platform engine, so we have this platform engine, the API, and the developer experience. So this is how we have these 3 layers categorized in Open Choreo. So I'm going to go through each of these, how it's implemented in Open Choreo. So when it comes to platform engine, of course, there are so many tools. Like if you see the CNCF landscape, there are so many projects, cool projects that you have to, you can go and get started with. So for the Open Choreo, we have chosen preset of tools that we will be using. Like for example, we have, of course, we have Kubernetes. We have Cilium for network policies. We have OpenSearch for log indexing. Likewise, we have selected predefined projects. We have glued them together and have created this infrastructure layer. And it's not only about creating the infrastructure layer. This also has to incorporate a system architecture. So when you see this, there are different planes that we categorize. So now the data plane. The data plane is where the actual workflows of yours gonna run. So it could be your services, it could be your web applications, you name it. Even your AI agents could be hosted here. So to run these workflows in the data plane, there should be a workflow plane which actually does these CI workflows, the building images. So that is what the workflow plane here. So when these two are up and running, so we have to observe what's happening. So the whole point of this platform is to have an observability end-to-end from your code to the production system, what's going on. So these metrics will be captured in the observability plane, and all these are operated through the control plane. So this is the brain of the whole platform. So the actual brain is the abstraction layer that we have introduced. And so I talked about that we have pre-selected certain tools, but of course the batteries are included, but we also have an ecosystem where you can bring in your own. So for example, if you want to go with OpenObserve rather than OpenSearch, you are welcome to do that. So we do have an ecosystem where you can remove. So to get started, we have packaged everything together, but that has different customization endpoints, which you can easily plug in, which would work for your organization. And that's where we do have these open choreo modules. So there are verified core modules, and there are community-led modules. And if you have certain requirements which are not available, you can create your own as well. And now we have their APIs and abstractions. We talked about the platform engine, and now the API layer. So now we have the platform API, which abstracts the platform runs, and then the developer API. So for a developer, when he's creating a project, creating a service, how we will start? So there will be a project. So for each sprint, there will be certain changes that you will be introducing. So there's a project, there will be components. The components will be using certain resources. These services will expose some endpoints. So it could be a gRPC endpoint, it could be a webhook endpoint, and these will have dependencies across certain environments. And this has to be monitored in a way. So to understand, so we have a project boundary. So for this project boundary is something like, it could be each development team has a project, or else this project could relate to a business domain. Like if it's an insurance company, it could be one project where you use the customer specific data. One is about processing the claims. So based on your actual business requirement, you will classify the projects, and under that, you will have different components. This could be services, it could be scheduled tasks. So the types of components could be different. And these components will expose endpoints. So this is how things will be getting exposed to the rest of the stakeholders. And there will be dependencies. So for example, there can be intercommunication between these components. So component A has a dependency with component B. So how do you map it? So we do have a way where you can create a connection between component A and the component B. So the component B's reference is kept on component A. And when you're actually going and deploying this across environments, this reference stays intact. So you don't have to do this again and again. So this is done through the abstraction itself. And then the dependencies could be a third-party dependency as well. So if for some reason the services have a direct connection between the database, you can do that as well. And of course, there's a workload. So there will be, each component will have its configuration, and this configuration would vary accordingly according to different environments. So we have to capture that as well. And when you have this, so the control plane, what it does is actually compiles these different things, and it translates this to the Kubernetes namespace. So you can see each project is correlated to a Kubernetes namespace, and each component, depending on which component type, it will be a Kubernetes service, a deployment, based on which endpoints. So these will be correlated. So the actual control plane does this abstraction. So the actual developer would only go and tell, okay, this is my component, this is the code. So this, I have written this code in Go, and I'm going to go and deploy it. So he will connect the code repository with the control plane. The control plane will, based on the configuration he has done in the in the control plane itself, it will go and translate that to the Kubernetes artifacts. So this is the abstraction we are talking about. And when we are talking about this abstraction, so there are project types, component types, traits. So traits is something where like certain things, like for example, if this gonna support API key, so this additional API key support has to be intact across different services. So how do you do that? So these are different modular functions that you can plug it in. So we support that as well through OpenCoreo. So now we talked about like how we design these different projects. So let's see how it translates to the runtime semantics. So now I told you like when there's a project, it will correlate to a namespace, a Kubernetes namespace. And we use an architectural style called cell-based architecture. So for each project, we have it as a cell. So that is an encapsulated cell which defines the boundaries of that particular project. So within the project, there will be a lot of services. And you can see for the, so for anything that is exposed to the internet, there would be a standardized gateway which goes to the internet. And for intercommunications, it will go through the internal gateway. So everything is guarded. So it gives you a zero trust security intact. You don't have to do anything extra. Anything exposed will be done through a very secure manner. So so you can see the northbound ingress, like how these are like each from north to south, west to east, anything would have their own authorization method. Like we normally use an oath, and we try to see that the security is in place end to end. And now, so we have this abstraction layer. So then now we have to provide on top of this a developer experience. So the developer has to come and really work with these different abstractions. So that is where like so in earlier stage, we have these APIs in a traditional way where you have these different APIs and you create your portal. And that's where the actual developer comes and tries to see how to do different tasks. But the actual win is when you meet the developer where he is. So nowadays, some developers would be very used to CLI. Some people would like to use their code agent. So you can use our MCP server to really go and connect to our platform, or else you can have a UI. So we are packaging a default UI, which is on top of Backstage. So you can go and have a self-serving portal as well. And this is about the support with MCP server. So you can actually connect your Cloudy code, and you can just, this is how it will perform and task as a platform engineer. So now here we have, so we talked about 3 layers, the platform engine. Then we have this API abstraction layer, and then the developer experience. Now you can see in the rightmost, the platform engine is where you have these all different planes, and the center is the actual abstraction, which is the control plane. And then if you see to the leftmost, that's where you give the experience that is expected from a developer. And through this, what the end goal will be, so there will be different personas in your organization. So it could be a developer. So his aim is to build and deploy and try to get his code into production. And then there will be different C-level folks who like to really see what's going on, the governance side of things. So that's where the observability plane comes in. And we also have the AI agent support. So we will talk about in the next slide. And also about the architect. So the architect has to come and see. So you might have a project with a lot of services, but there might be services which you might have designed that there will be a happy path, but those services would not be really in the runtime code. So you need to have that insights, and that's where the cell-based architecture and the observability towards across it helps out. And then we also have the SRE DevOps. So everyone can work together through this platform. And I would also want to highlight that we also have a first-class support for agents. So we can bring in external agents. So you can go and bring your external agents, deploy it in Open Choreo, and you can do the same software lifecycle with that. Or else, we also ship some inbuilt agents. So this is to actually create more robust operations. Like if there's something goes wrong, so the RC agent would really see what has gone wrong, and it will create the root cause analysis by itself. Likewise, we also have bringing in a lot of in-house agents as well. And it's a pluggable model, so you can bring in your agents as well to this ecosystem. And now we talked about these different planes. So the next question would be, how do you deploy this? So whatever we have, so this has to be a production-ready deployment. So these planes have the flexibility to, like on a Kubernetes, like you can have it in different ways. So there are organizations would like to have everything in a one single cluster. So we do support that. And there are customers who like to really separate only the data plane and everything else in one Kubernetes cluster. We could support that as well. So this deployment is very flexible. So you can have whichever fits to your organization can be deployed through the Open Choreo. So in summary, what you get with Open Choreo is what I have highlighted here. So there's a modular architecture we talked about, the platform APIs, the developer abstractions, the built-in agents. So there are quite a lot of things that comes within the Open Choreo platform itself. And this is the Open Choreo. So we are a sandbox project, and we do have an active community. So you can actually scan the QR code that leads to our GitHub profile. And if you think that this would something meet your requirements, give it a try. If you like it, give a star for our GitHub profile. And we are trying to go to the next level for the incubator state. So for that, we need more adapters and traction. So give it a try and let us know any feedback. And I would like to end my talk. So Open Choreo is one blueprint, but there will be teams which are building by themselves. So what you have to focus is when you are building the platform, don't make the developers to do this, the infrastructure level things, and the abstractions are the contract. So you have to get them right. So I forgot to mention, so we are in an internal developer platform space for more than 6 years. So we had a SaaS offering of internal developer platform, and with that learnings only, we created this open source project. So for us to get these abstractions right, it took like 2 years. And so we wanted to get that as an open source version, and that's the project, and that's where we have this Open Choreo. And also, when you are having this contract, it has to meet every server. So it has to be humans as well as agents, because agents are now within the ecosystem itself. Yeah. Yeah, that's pretty much. Thank you.
Yeah. Right. So we have quite a few questions. So how straightforward is the upgrade of Open Choreo components across all of the planes?
You don't, like when you're upgrading the components, it doesn't really, you need to go and upgrade the planes. So those are two different things. I don't know who.
Okay. In the Open Choreo, like I'm using the.
Okay. Okay. So those we do like weekly releases, so you can get it and upgrade it then and there. Like It's not that every plane will be, so we do have a release note and you can see what are the changes and you can update it.
Okay.
Quiet down, so.
Does it require downtime?
No. Yes.
Okay. How do you make variations to the one service across different environments, e.g. different memory sizing, scale, affinity rules?
Yeah. So when I talked about the services, it has its own way of like where we have abstracted where you can configure the DevOps. So you can, for each service, you have the privilege to go and tell, okay, how much memory sizing, how do you want to scale it, how many pods maximum you have to scale, whether you need to, so we do have something called where you won't have any scaling if there's no active traffic coming in. So we do have different techniques inbuilt, and those are coming through that API abstraction. Yeah.
Okay. How do you manage teams that have dependencies on other services, but each team is trying to make upgrades which could break the other's code? Usually there is an abstraction layer, such as an API gateway, which manages the versioning and subscriptions, etc.
Yeah. So whenever you are exposing that component in Choreo, that is exposed through an API gateway. So it is inbuilt within the system. So when I talk that there's an external facing gateway as well as internal gateway that monitors these communications, and that's where. And when you are really creating these connections, so we do have a way how the connections are made and upgraded as well.
Okay. Okay. How do you position Open Choreo in place of Backstage?
So Backstage, so we are using Backstage only to give them as an internal development platform, the UI. So it is just used as a component for the UI, but it does more than what Backstage does. Yeah.
Okay. I guess, do you require Backstage?
No,
run it
we
then,
do
or-
have the underlying APIs, so you can create
Okay.
your own developer experience as well.
Who is too small for Open Choreo, and what should they run instead?
Nobody's too small.
Okay.
So you don't really need to have all the planes. So if you want to just get started with a data plane, you can just have a single data plane and run it as well. So you don't have to have all the observability and everything. So it's a pluggable modular architecture. So whatever works for you, you can run it. Yeah.
Okay. You've already got an MCP agent for Open Choreo. It needs a name. I'm proposing Srini come deploying. Serious but underneath, once the interface becomes Ask the AI, haven't we just abstracted the abstraction that abstracts Kubernetes? At what layer do we stop?
It's a good question.
You never stop abstracting.
Yeah.
That's development, isn't it?
Yeah, this is why we have jobs.
Yeah.
I like this strictly come deploying. How do you configure Open Choreo? I think you mentioned there are no YAMLs involved, but is it all done through point and click?
No, I didn't mention no YAMLs. It's less YAMLs. So there will be YAMLs, but not too much YAMLs. That's what I meant. Yeah.
Okay.
Less for the developer.
Yeah.
For the platform engineer.
Platform engineer. Yeah.
Yeah. Every leaky abstraction looks like the right one on day one. What makes Open Choreo different from Backstage everyone's now ripping out?
Okay. So this is kind of more flexible, and it's something that gives you more autonomy of how you create things. And as I mentioned, Backstage is not something within the ecosystem. It's something that we have used to create the developer experience. So it's just one subcomponent. Yeah. I don't know whether I answered it correctly.
I think we're going to do one more question. Open Choreo intentionally abstracts away much of Kubernetes from developers. How do you ensure that those abstractions don't become a security blind spot? Specifically, how do you balance secure by default guardrails, e.g. workload identity, network policy, secrets management, SBOMs, supply chain? Oh, I think we actually run out of space for the end of this question. Okay.
So with that, what we're doing is like for each component itself, like we have a very tight network policy in place. And also we do have different guardrails, like we do have an inbuilt gateway, which is getting inbuilt within the ecosystem as well. So there are multiple layers of security in place to make sure that we have a zero trust based architecture. So yeah, it actually comes from the architecture itself.
Okay. Okay, we are out of time. Thank you so much. A round of applause, please. Okay, and that is it for us for tonight as well. So I want to say thank you to everybody for coming. Thank you so much for all of your questions to our speakers. We will be back here in this space for the foreseeable future. So we're back on the first Wednesday of every month. I am not here for the next 2 months because I'm traveling. So there'll be a different host for the next 2 months. And now for those who would like to join us at the pub, we're going to go to the conductor. Please return your key fobs on the way out. And thank you very much.